What's up, everyone? Welcome back to the channel. This is Johnny with Pirates Garage, but today I'm going to drop some knowledge on you. Now, before I get started here, I'm no expert. Don't claim to be. That's just all there is to it. But over the years, I've gained some, we'll call it experience. We won't call it knowledge, we'll just call it experience. So, we're going to do the difference between a MAF sensor and a MAP sensor. So, MAF and MAP. So, and I have Nissan, so this is the main thing for me. So this is the top of your air box for your, like if you change your air filter, this is where it's at. And this little guy is usually bolted, bolt like that. He's usually bolted on the side of that. So, this guy is called a MAF with an F, MAF. Mass Air Flow Sensor, I think is what it is. So what this guy does, he tells your ECU, your computer in the car, how much airflow is coming through there, and it comes through this little air thing. It tells your car, hey, there is whatever, I don't know what their unit of measurement is, but we'll say like there's 3 psi of air coming through here. So then the computer in the car takes that information and says, oh hey, there's 3 psi coming through, let's dump 3 pounds of fuel into the car. So that way it can do your air fuel ratio, which there's a whole thing with that. But anyways, just how these things work. So what I'm going to show you is, and this is the side that goes on the air box. You can see in there, which you probably can't, which I have no idea what did in the flashlight. Alright, so if you look in there, see there's two itty bitty, they look like diodes up in the top up there. So that is, you really can't see it, can you? So there's 2 fingers hanging down, and what it is there is a resistor of sense across it. And whenever the air blows through this, the engine actually is a vacuum, it sucks it in, but when the air blows through here, it'll go across that, and based off of the density of the air, this knows what to tell the ECU. So, this thing has, again, there is, if you see there's 3 pins in that plug. So in standard, this plug right here, there's 3. There's 3 pins on that plug that plugs into the ECU. And what happens is, it's easier for me to show you. We'll do it live. We'll do it this way. Okay, so one of those pins will go to ground, which I'm doing this upside down, so which ground's ground. It usually goes to the ground of the ECU. If you're doing troubleshooting, you can go to the ground of the car. It's preferred you don't do that because you can get interference in it. And the wire that goes from the ECU to this plug is usually, it's called shielded. So the wire, you have 3 wires in it, and around the wire is a shielding of metal. I don't know what it's made of, but it's like a metal sheath, and then the plastic sheath on top, a rubber sheath on top of it. And that keeps any outside noise or frequency from going through those wires to interrupt the signal. So we have a ground on this end, and in this one we'll say it's power. Oh. And when I say power, I'm talking 12 volts. So you have power and ground coming into this mass air flow sensor. Now this wire will go, I mean all 3 of these will go to the ECU, but this wire will go to the ECU, and instead of it getting power or ground, it is giving voltage back. And if I recall right, on the factory one of these, it goes from 0 to 5 volts. So based off of that, whenever the air blows across that little sensor in there, it will sense how much air density is going across it, and based off of that fraction of density, it will respond with a voltage. So it's getting 12 volts. So sitting here holding 12 volts, and the wind blows across it, and it says, feels like a 3. So then it sends 3 volts back to the ECU. And based off of that information, the ECU says, oh, hey, I have 3 volts coming from the mass airflow sensor. I need to dump whatever, 3 pounds, 50 pounds, whatever it is, whatever the math is in the ECU. But the good thing and bad thing with these. So the good thing is, honestly, I really don't know if it is a good thing. The problem with them, okay, we'll go with cons. We'll just do the cons. So the issue with these are, you have to be a minimum of 12 to 18 inches. They recommend 18 inches plus away from the intake. And you also have to have a filter of sorts on the end of it. The other con is they're prone to fail because just of where they're located. I mean, they can get false read. I mean, you can have all sorts of problems with mass airflow sensors. Most newer cars are MAP sensors, and a lot of the issues are fixed, which we'll go into that here in a minute. But mass airflow sensors, they get dirty. They get, like I said, if you do a turbo application, like I'm doing the turbo application on this, we're replacing the factory turbo and putting that big honking thing I have there on. I'm going to have to go to a MAP sensor because I could put the MAP sensor on it, but this is only it's going to limit how much fuel and boost I can run. Because, like I said, this does, we'll say 0 to 5 volts. That turbo on this mass airflow sensor would actually be like 9 to 10 volts was what it would actually need to run correctly. It's going to max out at 5 volts and say, I have no more, I'm done. So then you can move up to the Z32 MAF, which is a better MAF. It has a little bit more of the frequency, the 0 to 5, it has more of a range to give you more input into the ECU to give you more horsepower. And then you can actually switch over to a Mustang, they call them Mustang mass airflow sensors, which could give you even more. I don't think there's a max on those. I could be wrong. But I know that a lot of the people with big horsepower, like 800 horsepower, 500 horsepower, 800 horsepower, they go with the Mustang ones. If they run the math, they go with it to get the better reading. Alright, so this is a MAF sensor. Now a MAP sensor is a mass air pressure. So it actually looks like, which I don't have one here, it's a little black box. It's a square, and then on the back of it, it has a little kind of like a barb hanging off the back of it. And usually there is a hose run from it to into the intake on a car. So that way it gets live data based off of the pressure in the intake manifold. So the more pressure you have, the more pressure it's going to put into that sensor, which in turn is going to tell the ECU, hey, I need more fuel. And there's good and bads. So the bad is if you have really high pressure, so if you have a bigger turbo or, well, supercharger you don't have to worry about, but a bigger turbo, it can actually put too much pressure on that sensor. And I've actually seen it blow the hose off. I've seen it crack the hose. I've seen it actually break the diaphragm inside the MAP sensor. But with normal people, normal 300 horsepower, 500, like normal builds, a MAP sensor, just a standard MAP sensor is fine. A lot of people will take them from Chevys, which are fine, like Corvettes or whatever, because the MAP sensor is designed for those higher horsepower engines, and they're they're basically plug and play. They usually have 4 wires on theirs, and they actually have 2 grounds. So you'll have a ground to chassis, ground to ECU. You'll have a 12 volt, and then you'll have another wire for the actual map sensor inside, based off the pressure. And it also reads vacuum. So on the standard intake manifold on a normal car, it actually, like if you're sitting idle and just like not running the car and it's just sitting there idling, it'll actually have a vacuum on it. So that is the engine actually just pulling air into the engine just based off of it running, so that the compression and all that stuff actually creates a vacuum into the engine. Well, actually, technically, I guess it would create a negative pressure in the intake, which in turn pulls the air into the intake. I think, if you want to be technical about it. But anyways, so when you add like a turbo to a car, you are taking the natural vacuum from the engine. So we'll say naturally it can pull 10 pounds in. You take a turbo and you say, okay, you can have that 10 pounds. I'm going to give you 10 pounds on top of that 10 pounds. So it's going to take, so normally it would be a negative 10. So the turbo is going to push, and it's going to cause the intake to go from negative 10 to 0, and then to 10 plus, which is where the boost comes in, where it pushes air in. So the mass air, well, either one, the mass air flow sensor or the MAP sensor reads that change in pressure in the intake. Well, the MAP reads the change on the intake. The MAF reads it before it goes into the turbo and then gets compressed. That's another reason why the MAP is better than the MAF. But anyways, it reads that and it comes into there, and then based off of that information, you can actually go into if you have a tunable ECU, the ECU can actually adjust itself to jack up the fuel based off of that. And if you get really fancy in the ECU tuning side of it, you can actually take that information based off of all that and actually adjust the timing and all that kind of stuff to adjust for the best air-fuel mixture in the cylinders. But I hope that was educational. It was a lot to take in. It can get really confusing, but if you can take the basics of it and take the knowledge of it and apply it whenever you're working to troubleshoot or you're working to build, like we're building this car, this engine, if you can take that knowledge and just use the basics of it, you can figure a lot of things out based off of whether or not the wiring's correct. If your car goes into limp mode, which is the car will run but it won't go above 3,000 RPMs, I'm going to say 9 out of 10 times the mass airflow sensor is bad. That's with a car that has a MAP sensor on it. So whenever it goes bad and the computer cannot read the signal coming from the mass airflow sensor, the ECU has like a default mode it'll kick in to keep itself safe from being from just blowing the engine up. And what that does, it keeps you from going over 3,000 RPMs in order for you to limp the car to the mechanic. That's why it's called limp mode. That could be caused by several things. It could be caused by a broken wire, a loose connection, the resistor inside of the MAF sensor actually breaks. I've seen the solder come off from being jerked around. If somebody wired in a new plug, it could be because they used a non-shielded wire instead of a shielded wire. There's a lot of things that can happen and a lot of ways to diagnose and figure out things. But like I said, as long as you can pick up the basics and understand how things work, you can start eliminating things on engines, because a lot of the time engines are real simple. It's air, fuel, spark. Those are the 3 things you need to run. And with modern engines, they have complicated that tenfold. So when I say air, they could, like on an old car, it's a carburetor. The only air is through the air filter. These kind of cars, air is only coming through the air box through a hose that's this long. I mean, newer cars, they have air lines and vacuum lines and collector boxes and they got like 10 feet of plastic pipe before it even gets to your engine, and it like veers off and has little canisters hanging off of it, and they overcomplicated it. So if you can understand the basics and understand what is needed to make an engine run correctly and what to diagnose what you need, and if you understand these, like, you understand that what this thing does and how it works, and based off of like knowing the 3 prongs, one has power all the time, one has ground all the time, one has a variant of power coming back to the ECU. You can hook a voltmeter up to one of these and say, hey, I ohm it out to ground. Ground's good. I get 12 volts onto the one plug. I'm good. I have no signal coming from it. I have no. If you give it gas, you do anything, it never fluctuates. Okay, it's broke. The inside's broke. So there's no way for it to tell you one way or the other. Or if it doesn't ohm out to ground, you could have a bad ground, which you can run a jumper to the ground to see if it works. If the 12 volt power is not there, then you know there's something wrong between this and the ECU for 12 volt power. But anyways, I'm done for the night. I'm tired. It's late. I hope this is educational. Thank you guys for tuning in. I really do appreciate it. Please like, subscribe, share. I'm planning on getting more of these types of videos out, trying to explain the way things work. Because I personally feel that they're better than you watching me clean up a rear main seal. But all right, thank you for watching, and hope to see you next time.